Imagine a line of students at point parade, arranging themselves by height, one student at a time. That's insertion sort, the simplest sorting algorithm inspired by real-life ordering. Picture the PT lineup. A sorted line grows on the left. Each new student compares backward, shifting taller students right, until they slot into their correct gap. Repeat this for everyone, and the whole line ends up sorted. Take array 5, 2, 4, 6, 1, 3. Key 2 compares with 5, shifts it right, inserts 2 first. Key 4 compares with 5, shifts once, settles between 2 and 5. Key 6 stays put, it's already larger. Key 1 shifts past 6, 5, 4, and 2, landing at the front. Finally, key 3 slides past 6, 5, and 4, resting after 2. Sorted. Insertion sort runs in O(n) time on nearly sorted data, and O(n) superscript 2, worst case. But for small arrays, its low overhead and simple in-place swaps make it faster in practice than heavier algorithms with more overhead.